What is teleportation? In conventional science fiction depictions, teleportation is where a device scans an object, dematerializes it, and transmits it to another location where the object is rematerialized back to its original state. But is teleportation just a fictional method of transportation, or could it one day be possible? In 1997, two groups of physicists, one led by an Anton Zeilinger and the other by an A. Francisco Di Martini, both carried out the first successful teleportation of a single photon. Each group used a technique based on insights reported in 1993 by A. Charles Bennett of IBM. These insights relied on something known as quantum entanglement. Quantum entanglement is a strange, intimate relationship between two particles, each of these particles being in the same quantum state. When one of the particles changes its spin, the other will follow in exactly the same way, instantaneously, regardless of spatial separation. The teleportation method used by Anton Zeilinger and A. Francisco Di Martini is known as quantum teleportation. Quantum teleportation is where the specific quantum state of a photon is measured and sent to another location where that information can be used to manipulate another photon into the same quantum state. However, the act of measuring the quantum state of a specific photon will cause that photon to move into a new quantum state. Therefore, the quantum state of the second photon will not reflect the quantum state of the first photon before measurement. So say we want to teleport photon A to a distant location. The first step is to have the entangled pair of photons B and C being at the destination. The next step is to not directly measure photon A, for doing so will disrupt its quantum state. Instead, we will measure a joint feature between photon A and the entangled photon B. By doing so, we will learn how photon A is related to photon B, and since photons B and C are entangled, we also learn how photon A relates to photon C. This information is then communicated to the desired location through traditional means, such as telephone, fax, or email. Once the other side receives this information, they can use it to manipulate photon C into the same quantum state as photon A. And since the act of measuring photon A will disrupt its quantum state, quantum teleportation has been achieved. Although modern science has successfully teleported a single photon, even the smallest objects are made up of billions of particles. Therefore, teleportation by this method is not practical, although it is theoretically possible.